All right, let's look at how we can get between rotational and linear quantities. And when I use the word linear, some other words that might pop up, tangential, because these are going to be like distance and speed because we're talking around that arc of that circular motion. A good thing to do is make sure you have this sheet filled out at the start of your packet so you can go ahead and identify what information we're being given, what information we're trying to find, what variables those are, and then we can get those correct equations used. So let's get started on this. A model of a helicopter rotor has 4 blades, each 3.4 meters in length from the central shaft to the tip of the blade. The model is rotated in a wind tunnel at 500 revolutions per minute. What is the linear speed in meters per second of the blade tip? So I'm trying to find linear speed, so I'm trying to find V. But what did they tell me? It was being rotated at 550 revolutions per minute. What variable are they giving me there? So if I look at that sheet, I'll see revolutions per minute. That's either telling me the frequency or that's telling me omega. Omega and frequency are going to tell me the same thing. We're going to learn about frequency, I think, on the next page. But remember, omega needs to be in the correct units of radians per second, okay? So let's go ahead and get that 550 revolutions per minute into radians per second. All right, so now that we have that conversion written out, we have 2 pi radians per revolution, 60 seconds per minute. Go ahead, plug all that in. You should get a number of 57.6 radians per second. All right, so now that I have omega, in order to find the speed, V, I'm going to need to multiply omega that I just found times the radius. And so they said that radius was 3.4. So V is going to be omega times R. So I'm going to take my omega, multiply it by that distance, which is that 3.4. And we should get 196 meters per second here. Now in the back of your head, you might be thinking, Mr. Foster, you just did 57.6 radians per second times 3.4 meters. I get the 196, but I see radians here, but I don't see radians over here. What happened to it? And that comes back from before when we talked about theta is S over R. S is in meters, radius is in meters, and meters divided by meters should give me no units, but we give it radians as kind of a placeholder, as information about what that number represents. And so whenever we get a chance to substitute meters back in, we drop that radian. It's just a placeholder. It's not actually a unit, okay? All right. They also wanted to know, part B, what is the radial acceleration of the blade tip expressed as a multiple of the acceleration g due to gravity? Okay, radial acceleration. So they are talking about AC, which also is centripetal acceleration. Both those terms mean the same thing here. Again, you want to use that sheet about all the different variables, all the different names, so that you can get this stuff straight. This is very much a term-based chapter in that you got to know all the information in the wording. A lot of the algebra is going to be pretty easy to start with here. Okay, so I want to find the centripetal acceleration, so I have 2 choices. I can either do the speed squared divided by the radius or omega squared times the radius. Either one is acceptable since I have both numbers now. So AC, I'm going to go ahead and use the omega squared since I stored that number on my calculator and figure it out. So I have this 57.6 number stored on my calculator squared times 3.4 will give me a final angular acceleration of 11,279 meters per second squared, but they wanted that in G's. And so we'll remember back when we did that a couple times, 279 meters per second squared. We want to get rid of meters per second squared and we want to go to G's. And we know that the acceleration of gravity on Earth is 9.8. So go ahead, divide that by 9.8 and you get 1,151 G's. Okay? That is a lot. That is why these helicopter blades need to be perfect. If they are not, they could be torn apart and that would be catastrophic.